Hi, hello everyone. Welcome to Compiler Design Lecturer Series. I'm Dr. P. Naveen. Today we are going to learn the introduction to compiler design. First, we will understand what is compiler is. Then we will see why a compiler is needed. Okay. We will also learn about an interpreters and an assemblers. After that, we will understand how a source program became a missions program. So this is a introductory lectures. So I will explain every concept in a simple way. At the end of these lectures, you should be able to explain the meaning and the basic works of compiler. Okay, let's start. Okay, next slide, slide number 2. Why do we need a translator? Okay, so students, let us begin with simple questions. Why do we need a translator? We we write programs using languages such as C, C++, Java, or Python, right? So these languages are easy for us to read and write. For example, if we write a total is equal to price multiplied by quantity, so we can understand this statement easily. But computer cannot directly understand these high-level statement. Okay. So the processor understand only the machine level instructions like zeros and ones. So these instructions are represent using zeros and ones. So there is a gap. The programmers write in high level language, but the computer understands only the machine language zeros and ones. So the translators fill these gaps. Okay, it converts the programs from one language into another language. The meaning of the program should remain the same after translations. Right? Okay. So let's move on to the next slide. What is a compiler? Now, let us understand the meaning of a compiler. Compiler is a system software. It translates a program written in a high-level language into target programs. Okay. The input given to the compiler is called the source program. The output produced by the compiler is called the target program. The target programs may be assembly codes, object code, or machine codes. Okay. So a compiler normally check the complete program. It also find errors in the programs. For example, it can find a missing semicolons. It can find a undeclared variables. It can also find an incorrect statement. After the errors are corrected, the compiler generates the target code. The generated program can be executed many times. We don't need to compile it again for every executions. This is the one important advantage of compilers. Slide number 4, basic translations models. Look at the diagrams on the slide. On the left side, we have the source program. This is the programs written by the programmer. In middle, we have the compiler, right? We have the compiler. The compiler reads and checks the source program. Then it translates the source program. On the right side, we get the target program. Okay. So during the translations, compiler may display error messages. For example, consider this statement. Results is equal to A plus B multiplied by C. The compiler must understand the variables and operator. It must also understand the multiplication is done before additions. So compiler does not simply replace one word with the other words. It understands the structure of the statement, then it produces the correct instructions. Okay. Okay. Let's move on to the next slide. Slide number 5. Language processing systems. A compiler does not work alone. It is a one part of language processing systems. Let us understand the complete process. First, we have the source program. The preprocessors handle header files and macros. For example, in C languages, its handles include statements and define statement, right? Next, the compiler translate the program. Compiler may produce assembly code also. After that, assembler convert the assembly code into object code. Then the linker join the object code with the library files. Finally, the loader plays the executable program into memory. Then the program starts running. So remember this order. First, it comes preprocessor, next compiler, and then assembler. After that, linker, loader. Okay. So each tool has a separate jobs. Okay, got it? Okay. And let's move on to the next slide. Slide number 6. Compiler and interpreter. Now, let us compare a compiler and an interpreter. Both are language translator, right? So, but their working methods are different. Even though if both compiler and translator or the compiler and interpreters are translator, it's different. Compilers normally translate the complete program. After successful completion, it produces a separate target program. The target programs can be executed many times. Okay. An interpreter works step by step. It reads one statement at a time. It translates that statement. Then it executes the statement. After that, it moves to the next statement. Okay. So interpreter is usually does not create a separate machines program in the same way as a compiler. Compiler takes some time before executions, but compiled program usually runs after fastest. Okay, and interpreters give immediate output while checking the programs, but repeated executions may be slower. Usually we work on Python, right? So Pythons commonly use interpreter like C or C++ programming language. They are using compilers. So some languages use both the methods also. Even if you take Java, this now Java takes both compiler as well as interpreter. Okay, let's move on to the next slide. Compiler and assembler. Let us compare a compiler and an assembler. So as I told you, compiler accept a high-level language programs. For example, it may accept a C or C++ program. Compiler handlers compiler handles variables, functions, loops, conditions, and expressions. So its works is complex. And assemblers accept an assembly language program. Okay, actually compilers it accept variable functions, loop, conditions, expressions, but it can assembler only accept the assembly language program. Okay, assembly language is already close to machine languages. It uses short instructions like a name called mnemonics. For example, add, right? So the add may be represent an additional instruction. Similarly, if you have a sub represent the subtraction. Like similarly, if you have a mul represent the multiplication instruction. So assembly language is close to the machine languages. Here, the assemblers converts these instruction into machine code. So remember these difference. Compilers convert high-level language into low-level code. Assemblers converts high-level language into machine code. In many systems, compiler and assemblers works one after another. Okay, let's move on to the next slide. What happened inside a compiler? Okay, now we will see what happened inside a compiler. The work of compilers can be divided into two main parts. There are analyzers and synthesizers. During analysis, compilers study the source program. It separates the program into small meaningful parts. It checks the grammars of the program. They also check the meaning of the statement. After analyzing, the compilers create an internal form. This internal form is called as the intermediate representations. During synthesizations, the compiler use these intermediate representations. Then it generates the target code. Okay. So in the coming lectures, we will study each phase separately. So they include lexic analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimizations, and code generator. So for now, remember this simple idea. Analyzers understand the source program, synthesize, produce the target program. Okay, let's move on to the next slide called slide number 9, front end and back end. So compiler can also divide it into two parts called front ends and back end. The front ends mainly works with the source language. It read the programs, it identify the tokens, it check the grammar, it check the meanings, and it also create an intermediate representations. In backend, the backend mainly works with the target machines. It improve the intermediate code. It select suitable machine instructions. It use preprocessor registers. Finally, it generate the target code. So the front ends depends on more on the programming language. The backends depends on more on the computer processor. Okay. So this separation is useful. The same front end can be connected to different backends. Therefore, the same source language can be separated on different machines. Okay, hope you understand. Let's move on to the next slide. Slide number 10, error directions. The one important work of compiler is error detections. Compiler should find the errors and report them clearly. So there are different types of errors. Lexical errors occurs when individual characters or invalid words are used. In syntax errors occurs when the statement does not follow the grammar. For example, a close bracket. Okay. Suppose if you miss the close bracket, if you miss the semicolon, okay, the semantic errors occurs when the grammar is correct, but the meaning is wrong. For example, we may use variables without declaring it. Okay. So we may pass wrong number of variables to the functions. We may try to store a word inside an integer variables. So a good compiler tells the line numbers and the type of the error. Okay. So this helps the programmers correct the program easily. Okay, let's move on to the next slide, slide number 11. Why is compiler design important? Now let us understand why compiler design is important. First, compilers allow us to write the program using easy high-level languages. So we don't need to write easy every program directly into machines. Second, a compiler can improve the programs. So this process is called optimizations. It can remove unnecessary operations. It can reduce execution time. It can also reduce the memory usages. So third, the compilers support portability. The same program can be translated for different processors. Compiler concepts are also used in many other areas. They are used in database systems, they are used in text processing tools, they are used in code editors and development environment. They are also used in static analyzing tools. So compiler design is useful not only for creating a compiler, it teaches many important methods used in computer science. Okay. Okay. Next slide number 12, type of compilers. There are different types of compilers. Let us see a few important types. Single pass, multi-pass, and cross compilers. Single pass compilers process the program mainly one time. Multi-pass compiler process the program in more than one stages. Cross compilers run on one machines but produce code for other machines. So these types commonly used in embedded system. And also there's one other compiler called just-in-time compiler. We call it a jet compiler. It translates code while the program is running. Okay. Another compiler called source to source compilers. It converts the one high level language program into another high level language. Suppose if you write the program in C, if you want to convert it to C++, then this compiler will run the jobs. Okay. Other one is optimized compilers. So these optimized compilers try to improve the programs. It may take the program faster, it may reduce the program size, it may also reduce the memory sizes. A compiler can belongs to more than one types. For example, compiler can be a multi-pass and optimizing at the same time. And okay, let's move on to the next slide, slide number 13. Simple examples. Now let us understand compilations using a simple examples. Consider these expressions. Positions is equal to initial value plus rate multiplied by 10. First, compiler identify the variable names. They are positions, initial values, rates, and times. Next, it identified the operators. There are addition and multiplication operators. Compilers know that multiplication is higher priority than additions. So rate multiplied by time is calculated first. So the compiler may create the temporary variables t. One is equal to rate multiplied by time. Then position is equal to initialize value plus t1. After that, the back end changes. So these steps into machine instructions. It may load the values into registers. It perform the multiplications. Then it perform additions. Finally, it store the answer in positions. So these examples shows that compilers walk step by step. Next, slide number 14. Important examinations point. Students remember this important examination point. Compiler is a system software. It converts the source program into equivalent target program. It also report errors. So basic compiler model has a source program, compiler, target program, or error messages. Okay. So compiler normally translate the complete program. Interpreter translate and execute program step by step. Assemblers convert the assembly language into machine language. Front end mainly check the source program. Backend mainly generate the target program. So compiler is a part of larger system. The system may contain preprocessor, compiler, assemblers, linkers, and loader. When write the examinations answers, draw a simple black diagrams and also write one small example. So this will make your answers clear and completely. The next slide. So summary and quick questions. Let us quickly summarize today's lectures. So a compiler connect a high-level language and machine language. It accepts the source program. It check the program. It report the errors. Then it produce the target program. So interpreters translate and execute statement step by step. And assemblers convert assembly language into machine code. The compiler front end works mainly with the source language. The compiler's backend works mainly with the target machines. Compiler concepts are used in many areas of computer science. Now, try to answer this question. What is compiler? Why do we need translator? What is the difference between a compiler and an interpreter? What is the work of assembler? Okay, okay, that's all. So in the next lectures, we will learn the phases of compilers. Okay, thank you guys.